Okay, we need to get started. So let's see if people online can hear us. I'm going to pick somebody if you don't mind. I'm just going to pick Ahmad. Ahmad, can you hear me?
I can hear you.
Very good. We can hear you very well as well. Um, so when we get in, I'll explain what the class is about and how many people we have and who I am and what we do and for how long. But normally, this class is offered in three different ways. Some people are here in this room, and I will show you. Stop sharing. And then I'm going to show you this. Yes, that's me over there. And I can move this thing if you want. But I can also set it on the audience. And the audience, what do we have? Do I have anybody that, no. So let's see, the audience is, that's me. And then we have a bunch of people on that side and one person on the other side. So I'm going to guess just quickly, are you Jack?
Yeah.
All right, see, totally lucky. But oh wait. And then we have Sanmeet. And then we have John. And then we have Songwon. I think you can tell me and I can practice if I don't get it right. So then I'm going to go back to the instructors back. Me, I'm going to move that also. You can see that from the back. And then that's basically it. So online we have what we have. I have me twice, Alisa and Ahmad. And now we have one more person. This is Emma. Yes, it's me. That's right. And now I'm going to go and say, we're recording, we're going to share back to how we were before. And sharing means that we have an A47 over there. So we started around 10 minutes ago, recording. And why don't we just go away from this talk? Except, as I said to you before, I'd like to verify that people can hear us, and I spoke to Ahmad, that that's totally fine. And there may be more people online later. But usually, just make sure you can hear me. I'm just going to type a question. I don't know, let's try this one. Let's try this one. So I could just say, what does a dog do that a man or a woman steps into? This is the question. So let's say I'm asking Alisa, did you hear my question or not? Okay, Alisa says yes. So we got sound from Ahmad who was very clear. And then if you heard a question, do you know the answer? Just say yes or no on the chat. So Christian Scott is joining us. That's very good. Maybe we'll ask Christian. Christian may have heard this. So every time you're coming from outside IU, then it's going to be with authorization. And then if you come from inside the network, you're just going to show up over there. So let me just write this down. What was go? Over steps into. This is a question for people to just answer. So now, where are we at, John? Do you know? That's a tricky question, isn't it? So we can get it from Alisa in terms of yes, no. And people online can easily Google. You guys can Google too. This is a joke. So if you find the answer, that's great. Amit knows the answer. Do you know the answer? So let's just go one more time with Alisa and Christian. Christian, you remember the answer to the question or not? No, we don't get anything from Christian. Christian, are you there? We do not know if Christian is there. So Alisa, let me just assume I'm talking to you or John. But John didn't know the answer either. So that's the answer. You see? A dog pants, but I can step into my pants. If I don't, that is really weird. I just show up, yeah, forgot. So we have a bunch of people online and we have a bunch of people in this room. Then we are recording because I don't want to forget. And now what I'm going to do is we're going to go and say, now for the things I claim that Alisa can hear us, Ahmad can hear us, we can hear Ahmad, and I bet if Christian wanted to talk, we could. So I'm going to go now to, I'm going to close the chat. There's Chris coming in. That's very good, Chris. And now we have more people, see? So I'm going to go to the website that we have for this class. And as people come in, maybe we're going to check with them to make sure that they can hear us and we can hear them and so on. So it's an external website. If you go to canvas.ru, you're going to have to authenticate. I have to authenticate as well. And then I'm going to say, once I get in, because I authenticated earlier with a different setup, this one here is the class that we're talking about. It's called, has two parts. And then there are 3 groups of students in this class. I'm going to make this smaller. And in terms of the people, we have a bunch of people in there. They're right here. And in terms of the homepage for this is going to be this one. I posted a number of resources. There are 2 books and more things coming. And then if I come back, I'm going to click on this. And if I click on this, I am being taken to the same place as this. You don't even see the difference. See? This tab and this tab, they're identical. So click on this one, and we have the external website. Now, today is the 17th. So the plan is going to be, under these numbers, there should be some information as to what we're going to do today. Now, yesterday I emailed everybody, and I clicked, I put some information on 17th, and you can click on 17 right now, and then you get to see what it is. And I'm not going to talk about this today, but I'm just going to maybe refer to it if you ask me questions. But that's for you to look and see what we're planning on doing. Now I'm going to say these are the students. You saw them in the other side, but not everybody is in campus. I have 3 graduate students. Not everybody can attend, so some people will watch the recording. I have undergraduate students, except there's been like, you know, add, drop several times by some people. So from this list of people, Arnav and Shivam, they just changed their mind yesterday. They're not in this class. These are fictitious accounts. And then this is a group of high school teachers from all across Indiana, except Ms. Snyder, she's from Georgia. But she attended our workshop in 60. And our goal, they are sponsored by the Center for Quantum Technologies, which I'm going to show you, CQT, and I'm going to say Purdue, because Purdue is running the main center. This is a center that was established for good in 2022, but then the work to set it up was earlier in 2020. We had a proposal to plan, and then we got those awards. They were small. We then, the reason for planning in this particular case is that we had to find industry members in this emerging ecosystem, quantum technologies, and then we found those, and they are supposed to support. They pay $50,000 per year to be a full member, or $25,000 if they are a half member. And then this is yearly, so every year they have to pay this, otherwise they can't participate. NSF matches their funds, and essentially the research is funded by the industrial members. We currently, maybe I can show you who are the members. I'm not sure where they are. Right here. The current members are listed here. These are people from industry that have an interest in quantum and therefore decided to join these 4 universities. Indianapolis, IU Indianapolis, Notre Dame, IU Bloomington, which is where we are, and Purdue. And the center is at Purdue, and there have been 4 meetings, and the meeting in the fall is going to be in Bloomington, the first time. It's been Indianapolis, West Lafayette, and then South Bend, and now it's coming to Bloomington. So at the meeting in spring, I proposed that we need to pay attention to workforce development. I did chair the attack for workforce development in the QEDC, which is a big international 2021 international organization. And I said, if we care about workforce development, then I suppose the best thing would be to combine the long and short-term perspectives by going and providing materials and opportunities for professional development and maybe even help to change the curriculum to include quantum topics, which in the US doesn't happen. In Europe, it's a lot more ubiquitous and, common. Here, only Ohio and Texas have quantum topics on the high school curriculum. Texas, because of Karen Jo Matzler from Quantum for All, and that's in the physics curriculum. And Ohio decided to put on a quantum computation. No other state. And so teachers don't teach this unless they have an interest, a passion in this, or they're done with the AP and so on. So I said it would be good to go to the high school teachers if it's possible, sponsor them, and then they come and join. And currently, we have Chris of those currently attending, and hopefully yes. And then other people will show up, and then they also can watch the recordings. And this is who we are at this point. We have what, 5 people in the room, and we have 4 people online without me, and then we're starting. So the Center for Quantum Technologies has had different membership. Members decide to stay 1 year out and then come back. The way the center functions is by having an industry advisory board. The center has money from NSF and the companies that I showed you, which are depending on how we recruit, we change those. And the more the better. They ask the faculty to propose projects at the spring or fall meetings, and then they vote for them. So then I propose a very small funding required project to actually reach out to the high school teachers and see if we can provide them with the materials that could be used in the classroom, in a high school classroom as they are. So now I'm going to go back to this and I'm going to click on it. I wanted to click on this one, so I'm going to click on the syllabus. And I'm going to say, you have seen the syllabus before, I bet. And I want you to know that this class is called Introduction to Quantum Advantage because its purpose is to show you what quantum computing can do for you and how different it is. I'm going to assume that all of you are familiar with computer science. The high school teachers that have joined us, remotely or synchronously or not, they are also teaching computer science. They teach other things. In high school, they teach a lot of things, but they are mainly high school computer science teachers. So I'm going to assume that the foundation of computer science is established. And we can start from that. So then you look at this and you say, what do you want to bring up in this class? And especially if you say you want to make it as accessible as possible to people who are in high school. Then what's the structure of the class? So I'm going to say there are 6 weeks, and each week is going to have a theme. And you have 6 topics over here, and they might sound familiar or not, but they are cases of quantum advantage. They are cases where if you were to try to do that thing in a classical sense, you couldn't do it as fast as in a quantum sense. So for this, you need devices that work in a different way. I want to clarify something. This is not a course in quantum physics, although it's the 3rd time that we're teaching this class. And occasionally, we decided to argue that you need to know some quantum physics because otherwise you wouldn't have a good appreciation of how the world functions. Thing is that if you are going to be involved in building quantum devices, you should know the physics. Otherwise, you shouldn't. The only thing you should know is what some words mean and how they participate in your calculations. So you might assume that each week is going to have one of these topics as the goal. I have a textbook which I shared with you, and this indicates the approach, why the approach might be relevant for people who are, let's say, maybe very young, so they didn't have the chance to actually study mathematics and so on, or not young, but they didn't choose to study mathematics, and now they're interested in this. So the look of this argument here, at the beginning is like a dialogue, and later on, I didn't have time to stay with the dialogue, it becomes prose. But you will see that all the calculations are basically with little disks, which are white and black and curly braces. And this is because it takes the idea of a book called Cues for Quantum by Terry Rudolph, who's an extremely accomplished person. I will just briefly say that he was born in Australia, grew up over there, and then in Africa. He teaches in London at the Imperial College over there, and also got his PhD in Canada at York University in Toronto. Now he's leading a company in California while he's teaching in London. It's called PsiQuantum, which is using photonics, and actually they want to have 1 million qubits by the end of the decade. So extremely promising company in the sense that a lot of investments went into them. They got lots of money. They are very capable people, and he is a really good communicator and educator. When he finished his PhD, he found out that he is the grandson of Schrödinger. Schrödinger, one of the important figures in quantum mechanics. Next year, we have the International Year of Quantum, 2025. We have a club in here called Quantum Technology for Everybody, QT or QT. We had Quantum Day organized this year and last year. It was a bigger event last year. Maybe I'll show you more things about that later, but if you're looking at this, you will see that all the work that is done in here avoids mathematics, and here at some point, it says the goal is to learn mathematics. So from the beginning, you need to understand that there is a one-to-one correspondence between what we do with these circles and the actual math. And that in the process of doing 3 weeks of little circles, moving them around with simple rules, the simplicity is very well chosen and has good justification. You will, in fact, be exposed to how the actual math works. And then in the process say, well, let's graduate to the math. And you will find, I hope, and I need to know from you, that the math that you will learn seems suddenly familiar just because of these little circles. So I'm going to come back over here and say that Terry Rudolph has this book, which you see. I'm going to close the participants, and if anybody needs anything, just write in the chat or just talk. I'm going to ask you to please watch this video for the more as 20 minutes. I guess I can just run just 2 seconds of it just for you to see. I'm going to say share computer sound. I'm going to make stereo. And let's just watch 3 minutes, 2 minutes, 3 minutes, just for you to know how Terry talks and what he does.
G'day, folks. Today I want to teach you the first mystery of quantum theory. Quantum theory has many mysteries, but this is the first one. It's the most special. I'm going to teach it to you using only basic mathematics, and I'm not just going to give you metaphors and analogies and stories. I want to teach you the actual quantum theoretic description. Now, we'll start off by talking about a very simple system, which is going to be just a ball. And this ball can be either black or white. You might be thinking, hang on, quantum theory, isn't that about like atoms and photons and tiny things? And it's true, that's where we mainly use it. But if the laws of quantum theory are correct, in fact, they apply at any scale. And so, although the experiments I'm going to describe to you in practice we do slightly differently, in principle, they can be performed exactly as I describe. So we have this ability to take this ball, and it can be either black or white. So this is going to be the white ball.
So notice how that's a black ball, right? But he calls it white because he thinks he has something pink in his mind. So that's the kind of stuff that I ask you to please sort of correct to your minds. For him, he's writing on a white paper, right? And he doesn't put any ink inside. That's why that's white, even though that's actually black. This is on a blackboard, right? So then
and this is going to be the black ball.
Yeah. But this is irrelevant, right? This is irrelevant because that's the kind of stuff that you say and you really mean something else and you expect everybody to understand it. That's the only thing that this video maybe requires.
And we have many of these balls, but what we're going to do is we're going to drop them into a box. And this box kind of has a hole in the top and a hole in the bottom. And the label on this box is going to be not. Okay, strange label.
It's not not a strange label, but he's going to talk about the classical gate knot. And that's totally fine. You have to understand that what's going inside, in general, is going to be a qubit, which I will define as a linear combination or whatever. And the purpose of the knot gate is going to flip the probability amplitudes. But at this point, we don't know that. We don't care about that. And the only thing that you will have to worry when you're going to look at a quantum gate, this is a quantum gate, except it's also a classical one. But if you feed quantum states, then it's going to behave in a certain way for those states. So the only thing we're going to do is to actually describe them through the axioms. What does it do on the white ball? What does it do on the black ball? So the good part is that the good thing about this is, first of all, I'm going to, am I sharing the screen? I think I'm sharing the screen. I'm going to stop sharing the screen. And now since you see me over there, I'm just going to say this is a book. This is the book. It's a book. People in this room can see it, and people over there online also can see it because I'm moving it around. And everybody, all the teachers receive a copy, and you don't need a copy, but I think it's good to have a hard copy. And if people in this room want a hard copy, I have copies for you too. Just tell me, bring it tomorrow, and I will bring it to you. So I'm going to go back to sharing, and I'm going to say the reason you don't need this because the book is available over here. It may say draft on it, but it's the actual book. All right, so as you look through the book, you will see the drawings that he was trying to describe over there. And the entire book here, this is a knot that you saw in the very beginning. And you either put a white ball and it comes out black on the other side, or you put a black ball and it comes out white on the other side. Very easy. And things are going to continue to be easy as long as you are paying attention to the conventions that he is introducing. So this is a very simple system, but like any system requires that you practice. So in a second, I'm going to try to tell you what you're supposed to do in this class to get an A. I hope everybody will get an A and how we're going to function. I want it to be very simple. I want the structure to be very predictable, so to speak. And then for you to know what you are supposed to do. We have only one class per day. So in the beginning, you know, compared to the other classes, you do 12 or 343, we thought that we should have a lecture in the lab, 211 does that, 212 does that, and so on, right? Well, the academic operations director at the time said, if you do that, nobody's going to sign up because you're taking that time and nobody's going to have time because your class is going to be on a weekly basis or a daily basis anyway. So we only have one lecture. And I'm going to go back to this place and I'm going to say, you know how 17 is in fact, you're just looking at it, right? I'm going to go to 18, but 18 doesn't have anything. That's tomorrow, right? But let me start writing some stuff in 18, which reflects what I'm telling you right now so that you can go back and say, oh, that's what he wrote yesterday or he said yesterday in class. So well, I'm going to go with Putty, which I think is, we have, maybe if we don't have it, then will tell me. And I'm going to have to do something else. I can use SSH. This is an SSH client. Anyway, I'm going to go to Silo where I keep all the records. And I'm going to start writing what I'm telling you because this is the first day of classes and I want to write this down. You know, you already can read about the topics. I told you that we're going to start with those books, and I have a few more books to show. And my goal for you is to become literate, right? I don't necessarily want you to be fluent or expert, or you could become fluent. Expert, I think, I strongly suggest you take P555 after you understand everything in this class. You go to P555, you'll become an expert. I'm going to have to authenticate, but I do want you to know literate. I want you to be literate so that you understand the terms and say, sure, I can talk about these things. What am I doing? Where am I? Like right here. Wait, come on, I'm in. So I bet people don't see what I'm doing. Someone said change the settings a little bit. Colors, foreground is going to be like this. And then, okay, I'm going to go background. Modify and make it white, and then I'm going to say the foreground, the bowl is going to be red. So I set this up, and I do this beforehand. Except today, I want to do everything for you as we talk. And then I go appearance, and I'm going to change this. If it's 10, I'm going to make it 614. I'm going to make it 14. So this is going to be slightly bigger than what it is right now. And I'm going to go inside. I replace what I have. Stuff that I write in class, and I'm going to say, how about I create, I do have a C290, I bet. And I'm going to make a folder for some of the 24, which I don't think that's so far in the future. And I'm going to come back over here and say, look, this is my today 0616A.phps, and I'm just going to write an index that's in that thing. This is 17 actually. And let me just quickly say, first of all, I hope you know, this is my name, this is my email. I have an office upstairs. So the website, the office is in 2010. The class is called Intro into a Quantum Advantage. Okay, and then I'm going to come back here and I'm going to say, where's the class website? It's right here. Might as well say, might as well put it in here. I'm just going to say that this week, Monday, Tuesday, there is no class on Wednesday because of Juneteenth, but there's a Thursday class. So Wednesday would have been here, but no. And then we have Friday. Okay. Thursday we have a guest lecture. We have guest lecture this week, and then the last 3 weeks of the semester. The last 3 weeks we have it remotely from Oxford University. I posted titles and the abstracts. And if you say, well, I want to see how she talks, what kind of stuff she says, I'm going to go into 17, but I put stuff, and then go on the third one. This is the paper that she refers to. And then this is the playlist, because she has lots of videos online, and you can watch her here, and then you will sort of be familiar with the kind of stuff that she says and how. She's going to talk specifically to you, and you can ask questions, you can stop her. She will give you some assignments. Not for you to turn it in, but just to work on to make sure that you understand what she described. The presentation on the 20th is John McNally, and he's going to talk about what you can do with Mathematica from the point of view of introducing quantum to students. I want to take you to resources. And I have this issue that the website, the external website, is better for some, but worse for others. And then Canvas is better for some and worse for others. For example, people who are not yet in Canvas, Canvas is bad for them, right? But combined, this will cover the needs of everybody, and I'll try to duplicate. So if I go into this, I'm going to show you two things. I have this here, but I can just go back into 23, and I can follow the resources from last year. And these are the books that I can share with you. This Curious for Quantum. It's kind of like what Terry shows us on his website, but it doesn't have the graph thing. Yeah, in addition to this, because I was talking about the Mathematica, which is a product by Wolfram that also has Wolfram Alpha. And by the way, since you are at IU, you have access to Mathematica for free. And he can tell you how to get access to it if you want him to tell you. Otherwise, I can tell you, or people here at IU will tell you. So if you click here, you'll find a book that's done completely in Mathematica. And so everywhere to say, I want to study this software, I'd like to see what features it has and whatnot. Good news, we will receive information about that. This is Mathematica, as you can tell. And so Mathematica is an extremely powerful system with a lot of visualization built in algebra and the capability of calculation. I'll show you in Wolfram Alpha. Sometimes you just ask for something and then you get the answer without even knowing exactly how. For example, somewhere in the middle of this class, I'm going to give you the diagnostic quiz for people who decide to take 151 at Berkeley. That's a 100 level class, right? So it's at the beginning, but it's tough. So I think it's maybe at the level of a 400 level class here. So there's a diagnostic quiz at the beginning. It's actually brilliant. And if you say, well, can you show me what that course looks like? I have the ability to show you. You go under what's new. And if you look for playlist, you'll find basically Vazirani's lectures. And that's 151. So there's nothing wrong with this course. He's absolutely brilliant, and he explains things that are difficult in a very, very meaningful way. But he has a diagnostic quiz. And in the beginning, for example, if he says, can you find the eigenvalues and eigenvectors for this matrix? You say, well, I haven't started yet. And therefore, that's something that might just, frighten you in the very beginning. Oh, it's in the diagnostic quiz, and I don't even know what it means, if that's the case. So you can go to Wolfram Alpha and you can ask for eigenvalues or eigenvectors of a particular matrix, and they'll show you how to calculate. Then you learn, and then you know it, and it's also possible to solve the diagnostic quiz as you take the course. So I was showing you the resources. I guess resources are here. And then what else can I show you from the resources that I want to eventually post? I guess I'm going to say that there is a book that's completely free. This one here. And then there's also another book that's free. This one is quantum computing for high school students, but they have to be a little bit convinced that they are supposed to learn it. And it requires some math, but not all the math that it could require. So I'm going to come back over here and I'm going to say, in terms of this week, and forever actually, I'm going to say that the structure of the lecture should, could be as follows. Now, I'm telling you because we have not yet done anything except now, right? And I'm going to say we have 75 minutes and there is only lecture, no lab. So how is it supposed to work? So I'm going to say the first 15 minutes, perhaps today we can't do that, but we're going to come close to it. Should be something like questions from last time. Attendance. I mean, not that I'm taking attendance because it's part of the grade, but I want to acknowledge the people who are here or online. Just keep track. And the next 30 minutes, will be, okay, new material for the day. Okay, so today that's going to be Colab, Python, maybe probabilities. I should be careful here. Just get at least to know what these things are. And then the last 30 minutes, I'm going to say something like a lab. So we don't have lab, except we have lots of office hours. And if you want to make an appointment with me, I'll say Elma wants to make an appointment with me. It's going to work like this. He clicks here and it says, let me go to office hours. So look, the dates are listed by, it's a Thursday or it's the 20th of the month or whatever. And I do have I tested everybody is somewhere in there. So his username should be EPBUCHER or something. And right here, see? So let's say that he says, I would like to meet with you at, what is it, 6:17. How about I want to meet with you yesterday, just for the test of it. So then yesterday at 2 o'clock, I want to make an appointment. So he's going to choose the time and then choose, write down his the name and then click the button. And now he's listed at that time. I have disabled the ability of the script to email the student. It just emails me, telling me that there's an appointment, so I don't forget, so I don't miss it. The reason is they don't let me send email from this outside IU. And for the high school teachers that we have in this class, most of the emails, at least half, are outside IU. So because it's so non-homogeneous, it just sends me email. But your picture will show up over there. So for example, now, let me see if I can go back to participants. Who do we have? Maybe Chris said, whatever, this is, I'll come back with it. So, but let's pretend that Chris is here and Chris says, I also want to see you tomorrow yesterday at 3 o'clock. Then what I said in this list over here is if you are a student at IU, where is the students page? For example, John. Your username is John, open image in new tab, JGRUYS. And everybody with a username that's a student should be using that username. So for example, if you want to make an appointment with me, I put stuff in the past just for the test. So then I'm gonna come back and say, that's Monday. Let's say you want to see me yesterday at noon. Then you didn't get an email, but your picture is there, right? And for all the students that are you use your username, and that's fine. If you are a teacher though, you have to use, as you can see over here, the first 8 letters of your family name. So for example, in the case of Ms. Gelhausen, as you're going to shortcut to this, and in the case of people who have 8 or less characters, like for example, Chris Holmes, that's just going to be his last name. So now you know how to make appointments, and appointments are going to be only one. And if you're done with an appointment, you can make a new one. If you want to cancel, you cannot delete. You have to move it in the past. You already know how to move appointments in the past. So I would like then to say that up until now, I haven't done anything that involves you, but immediately you have to do something. And what you need to do is to create a GitHub account and then send me your username. So let me just submit. If I invite you now, could you also accept the invitation right away? Yes. Except I don't know your username, but if you tell me, I will. But I know Sanmeet because he took several classes from me. So let me see if I can find his GitHub. I'm going to go to A348. I'm going to show you now, and everybody has to do this. You have to make a free account with GitHub. So then you can then have a place that is just yours, that I also have access to, because I'll invite you. It's my repository, but then I'll invite you and nobody else. So each one has their own private. And then you work out something like an assignment to prepare for the Friday, Saturday, Sunday, whenever you want to make the weekly meetings. And when you come, you say, well, this is what I worked. This works. This doesn't work. Everything works. Nothing works. And I have some questions, or maybe ask me questions. And you can rely on that to talk to me about the week. So if I go on the students here, yeah, I don't know. I know I have to authenticate now. No, thanks. Okay, so I'm going to type this, and I think the situation is that since I haven't authenticated in a very long time from this machine, now I have to go and sign in with username, which I use at the time. So then I say that's my email. Next. Oh, that's the password. I don't want to, not now, come on. And she says, what? No, I don't want to be worried. I just want to verify my device. Sure. It's my device. Where is my device? I have to use this number. So, okay, things are going to be always a little bit slow because there's lots of parts that are moving, and we are at the very beginning. Put the thing here. I'm going to verify. I mean, this is you. You didn't submit anything on GitHub because you had on your website. That some people did use a thing, and I say settings, and I'm going to say that collaborators, and I am Sanmeet. That's your username. So what I'm going to do, once again, I hope everybody can hear me as well, is that going to the GitHubs right here, and I'm going to use Sanmeet, right? And since I just authenticated, there was no problem. This is C290 A590 6W2. I go and say settings, and this is something I did yesterday. I click on collaborators, and I'm going to say, I will now invite him to this account because he's the only one who's supposed to do this, plus me, is I have to grade it. Chris comes back, that's good. And I'm going to say add people, and now I put, that's his username. So when you create a free GitHub.com account, please remember it's not the GitHub.io, it's the GitHub.com. For example, we have people not from IU that should use the GitHub. And then the thing is that when I actually was deciding, should I stay with IU or the bigger one? The bigger one is bigger. If IU decide to discontinue this particular service, that bigger one is going to continue for sure. And they were telling us at the time that they were going to discontinue as well, 8 years ago. And then I said, fine, I pay like $14 or $7 a month to have an infinite number of accounts, and I use it in all my classes. So I'm going to invite Sanmeet, and it's free for you and very cheap for me. And he is now supposed to accept the invitation, kind of like in Canvas, but this is on GitHub. This will be the place where you should put your work. If you have some work that you've worked on that you want me to see, perhaps it doesn't work. And the benefit here is that you can post it, go to bed. Let's say I wake up, who knows where I am, what time zone. I work on it, I leave it on your account, you wake up, I go to bed, and then we've been essentially working on the same file. Yes.
So why have you worked on Silo if we can use GitHub?
I work on Silo.
But I can as well not work on Silo, and it's just written on my laptop.
Yeah, I did not create Silo accounts for you.
Oh, okay, easy.
But if you want,
you know,
I can.
it's okay. I have one.
Yeah. So 348, 548 needs Silo account,
yeah.
But this class doesn't need.
Okay.
So in no Silo.
Yeah.
I have to put stuff for class notes and so on
Yeah.
on Silo, like my external website. But don't work on Silo.
Okay.
There's no point. So that last 30 minutes of every lecture should be a lot because look, we have questions, but it is not a difficult question. But let's say I want him to accept, and I want everybody to see how that happens. So this is my email out. This one here is the 2 TAs from last spring. This one is with the office hours. We don't care about CBD anymore. We have second lecture. We're going to talk about it in a second. This is Canvas. That's my thing. This is John's page and picture. And if I reload, Sanmeet has accepted the invitation. So at this point, Sanmeet can post stuff. What stuff is Sanmeet supposed to post? And you have the answer to that inside the first lecture. And if you click on the 17th, now you could say, so can I get started? I want to do something. The answer is yes, you can do something. Here's what you do. Let's suppose you've read this and you click here on this link because it says, oh, we'll start with this document. And this document has 4 groups of questions. The first set of questions is about complex numbers. At some point, you have to learn what they are. What if you don't know what they are right now? Terry Rudolph says, and he has a proof, and we have a paper written with him that I can share with you. You really don't need complex numbers in quantum computation because you can double up the qubits. And you say this qubit is for the real part, this qubit is for the imaginary part, and there you go, no complex numbers. That's because we had a paper with the GAZ game, which I will show you, in which we use colors. He said, you don't need to use colors, you have black and white. And that's fine, sure, excellent, except you can do it both ways. So should you not learn about complex numbers? Absolutely, you should learn. Even he agrees with that. In the beginning, you can ignore them until at some point they become relevant. For example, you're going to learn about the X gate and the H, and you're going to learn about the Z gate, and there are no complex numbers. And then when you learn about the S gate, you at least need the I squared of -1. So complex numbers, I have some problems over here. Good news is that all the answers to these questions exist somewhere, and I'll tell you where they are. And what you have to do is to make sure that you understand what the answers say. The second group is what we're going to do this week. Everything in quantum computation is probabilistic. So I'm sorry if you find this surprising, then we really need to think about it every day until it no longer is surprising. You could have a perfect program that will randomly come up with the wrong answer at the end. But there is a 1-minute video on the Institute for Quantum Computation in Waterloo that says the key aspect of programming in quantum computation is to carefully organize the bad answers and the good answers such that the bad answers interfere with each other and cancel each other, thus limiting the probability of a bad answer coming out. And the good answers amplify each other so that increase the chance of actually getting the right answer. So if you actually run things on quantum hardware, you get probabilities of what the answer might be. We're going to use mostly Qiskit, which is a simulator or an emulator in Python, because our goal is to understand very well what's going on. And then if you ever want to work on quantum hardware, there are at least 60 companies that have quantum hardware. with at least 100 qubits in the world. And so you can work depending on how they provide an interface. You can just run it and it's going to be fine, but it will work just in Qiskit, except the answers will have some noise in them. So it is important to understand probabilities. So I'm going to ask you, for example, right off the bat, to work with me on problem number 1 and problem number 9. And you're going to say, what are you going to ask us to do? To actually write math and so on, because, hey, I'm going to drop the class. That's fine. I mean, you can always do this if you say it's too much math. My goal is to not put a lot of math. You know what the benefit of our field is that in this particular case, I can write a program to get the answers. Rather than use equations. And then I can actually write the equations too. And then I say, look, I can make them very simple and they agree with the program. So our first attempt here is going to be to use Google Colab. So let me just go to some Google Colab. And when I push the button, I bet I won't have any notebooks because I just authenticated as the other account of mine that is related to GitHub's. So I have several Gmail's accounts, and you too have to create, in addition to the GitHub account, a Gmail account, which you probably have. And I'm going to say, give me a new notebook. So this week and every week, we are going to create notebooks and use them to understand what the whole thing is about. And then we will meet on Fridays or Saturdays or Sundays, or maybe even Mondays for the week before, to just have a 20-minute chat individually to see if we understood what the idea of the week was. And the grade in this class is going to be the average of those exams. Every week, we will have a 20-minute individual chat. The grade for this class is the average. So this guy should go away. People online don't see it, but we do. Is the average of these 6 exams. Can I call them exams or interviews? Now, if you look into the description posted for today, the description that says this is what we're going to do on a weekly basis. At the end of every week, I say exit interview individually, summary. The summaries are cumulative. So then when is now after week 1, what do you remember was the highlight? And then week 2, what's the highlight in the first 2 weeks? But split it on week 1 and week 2. Sometimes some weeks are supporting previous weeks, some weeks introduce new stuff. And as I said, I have the list of things that we're going to do. So I'm going to ask, I don't know if people, I will try to involve people online because that's nice. Oh, I have something in the chat. Is the exams prior to this? No, there aren't any. So I want to meet with you 6 times, and that's it. No attendance, no no final, no homework, basically. Just lecture, structured as I said. 15 minutes. What? How was it so far? Anybody? Any questions? Do we need to make a connection with what happened so far? You know, like previously on C290. And then 30 minutes of new material where people who are coming asynchronously, they could say, can I just focus on those 30 minutes instead of 75 minutes? They could watch everything. But as you can see, this is right now all over the place. And in general, it will be even more all over the place because you will start asking questions and I'm going to provide answers. So we put the questions that we call lab at the end in the last 30 minutes. So hopefully that will simplify the task for the people who are remotely, not even in the US sometimes or on the West Coast or whatever. So how would you recommend we prepare for the one-on-ones? You could come to Zoom's office hours and you say, what are you going to ask me? You could ask me in class. Is this going to be an exam? And I think you're going to be less apprehensive after the first exam. So how are you going to prepare? You should do the reading assignments and you should try to verify that you understood on a daily basis whatever the thing was that we described today. So today I tried to tell you the structure of the class and we have like 25 minutes left. And I insisted that we are going to program in Python in notebooks and I was just about to get started. I showed you this and I said week number 1. So first of all, I don't want to challenge unnecessarily. So if you say this is going to be tough, no, it's not going to be tough. It's okay for you to come and say, I mean, I hope you're not going to just go for that. But if you come and say, I really didn't understand anything this week, okay, that's maybe possible. Have you, then maybe we should be more proactive and try to meet with me before. But if you say I couldn't, then fine. Show up on Friday, let's talk. Why didn't you understand anything? So I'll ask you some questions, and that will be my opportunity to give you one more explanation. One more time, some explanation. So my goal is to give you this information and make sure you understand it, not necessarily to set up hurdles and make it hard for you to go through those. Otherwise, you're not going to get a good grade. I would like you to get a good grade because the goal is to become literate. And I want to help you, even if you come on Friday and you say, hey, this is my weekly meeting and I'm not that sure with this week. But if you try, perhaps that will simplify if you try. And some people might, today maybe not, but some people might contribute in class. And in the process, I will be more sure that they know what's going on that week. So I could proactively, give credit, at least in my mind, or keep track of it, for people who participate in class. That's essentially the recommendation. Try to participate as much as you can. Stop me, ask questions, establish something that seems confusing at the time. Do not be afraid. So here's the rule that we have in this class, in all the classes that I teach. If I ask you a question and you give me an answer, the answer could be good, then you deserve all the credit for that answer. And if the answer is wrong, it's not your fault. It's everybody else's fault. So if you say something that makes no sense, you are excused. Everybody else is supposed to fix that. That's not your responsibility. Because maybe you're doing it on purpose, we pretend. You're doing it on purpose just to make sure that everybody else is listening. So you're never guilty of anything. That's why you could just ask, set up the discussion, and make it clear. Is this going to be on Friday? It's going to be on Saturday. I meet with you on Monday. What do you want me to review? We could review together so we can make an appointment in which I can tell you what I'm going to ask. And then 2 days later, we can meet again, and that's what I'm going to ask, if you want. I don't want you to be apprehensive. It's okay to be apprehensive. So I'm going to close the chat, and I'm going to say, besides this, which is probably for this week, I'm going to say that we have at some point to understand that there is linear algebra, and then there is the actual quantum mechanics notation. And as I said before, all the notation that we introduce to make it easy for sixth graders to learn this. I mean, I'm saying sixth graders can learn this if they are determined and if they have time and space dedicated to this. They can, okay? Maybe not all of them, but a significant percentage. Clearly, high school students can do better than sixth graders, and college students even better. All of them, though, should not expect that they know this from before. It's in my genes, I just wasn't aware of it. That's not true. It's simple, but it requires practice. So what I showed you over here is has nothing to do with the system that Terry introduced. This one has everything to do with the system that Terry introduced. But as we work with that, you have to be aware that we are talking, in fact, about the actual things that exist in quantum mechanics and quantum computation and quantum information sciences. So you'll see these things show up often. Maybe we can put this circuit together today or tomorrow, and you will see that at the end, when I say, give me the state, at the end, out comes the formula that the circuit is actually representing. It will go something like this. I hope you understand that that's basically the description. The grade is easy to calculate. All I want is for you to try to learn these things. And learning could happen during that exam. And I could just take the exam with you in which I show you how I would answer my questions. And then you come and say, so let me answer the questions. But I'd like to do something in the notebook right now, so I can show you how to submit the notebook. Is there any question at this point? Online or maybe in here? If you have a Gmail account, you can open, pull up notebooks. And I am going to show you one such notebooks. Okay, so let's see. I wrote this today, and maybe not much more. And this is somewhere nobody knows where it is, right? So I'm going to go on the class again, this is where I keep stuff, and you don't need to be there or have an account here, so I'm gonna go summer 2024. And I'm going to say, let me open 0618, which is tomorrow. $6.18. And this is the second lecture. That's for tomorrow. I'm going to say, please watch Perry's video. Okay. I'm going to also say, please identify the following. I want you to identify the following items on the website. Come on. So just know tomorrow where they are. Here's the items that I would like you to locate. Tommy Wong's book. So he's a professor of physics at somewhere in Nebraska. And Martin LaForest, whatever, guide. Terry's book. And the little qubits. These are the 4 things that we want to pay attention to in the very beginning. And we are going to start bringing up more resources as we go through this. So, all right. So then I'm going to say, here's what we wrote yesterday in class. This is for tomorrow, right? And that's enough with the. That's enough with the notes. I'm going to start putting together stuff in the notebook and then see what you think about it. All right. So what did we write? Well, I put stuff at this location, and as long as I provide a link, you don't need to know. 34315 slash, and I said it's going to be C290 slash quantum. Summer 2024, and the date was 06178 at PHPS. I thought I named it this. I put a dash because I. All right, not good. I'm writing today at all. I'm going to say if I click on 18, and if I reload, I get this, and I click on this, and that's my stuff that I just wrote. Okay, so then now we have everything in a place where you can rely. That's how you prepare for tomorrow. So where do you think is Tommy Wong's book? Where do you think are the other things? They're all in the syllabus. I want to say that we started with this, and we're finishing with this, and then we're going to do some notebook stuff. So qubits is here. You've seen it. We're really going to go through it. It has lots of challenges. We go slowly. We should finish in about 3 weeks before, and then we are going to start doing the same thing, but with the exercises for complex numbers, linear algebra, and the syntax of quantum mechanics behind us. We're going to do it in the right format. So it shouldn't be frightening or completely unexpected. Now I'm going to say that if you go on the syllabus again and you scroll down, this is the math primer that I'm telling you you should pay attention to, because other than the probabilities, which are taken from another class that I'll show you where it is, I say except all, this really is done for young students. So they are really good in Canada over there, and they invite high school teachers from all over the place, so they pay for them to stay 3 days. And we actually did go there and let's see, if I go over here, which is the class that the club that I past events. Let's see. Well, let's see. Where is that was in the past. The club website is here. So now this is completely entirely student archives, club proceedings. Yeah, okay. So these are my proceedings from when we started. It was supposed to be student journal club, okay? And these are so I'll share you. I'll share this with you. I may have posted them already. So these are things we did back in 2020 2023. And this is our little report from Waterloo when we went over there. Great, come on. So this will give you an idea as to what that workshop looks like. First of all, I have these things at home, and in fact, I can show you with the polarizers that if you use one polarizer, like you get whatever the TV is sending, which is already polarized photons. If you use another one, then you can control the polarization of the photons as they come out of the second one. So if they are orthogonal, then you get nothing. So two filters at 90 degrees cut the light. You don't see any light. And then you put a filter in between and you start seeing light. And the question is, why? How could you see light that you didn't have before if you have three filters as opposed to one? So I'll bring them and we can test this and understand and explain. And this is actually explained very well in Quasirani's lectures. But in addition to what they have to give people, they also have a lot of hardware. This is superconducting. This is ion traps. We also have ion traps here at IU. And this is the photonics lab. This is John Donahue. This is exactly how he has run the show. This is the classroom where this is actually 2 qubits used in superconducting modality. And so this is now this is basic physics. So I want to clarify that we're not going to do physics, except I'll mention something so that you have some appreciation for how nature works. But unless you go into quantum engineering, then you really do not need that. And if you go into quantum engineering, you should know that there are no labs that are so accessible, let's say at undergraduate level, because they're kind of expensive. At least refrigerators are needed pretty much at every stage, not as much as in superconducting qubits, but pretty much everywhere some kind of refrigerator is needed. So that's expensive. And so if you are going to be in quantum engineering, you have to understand, and it's going to be prohibitive. So not many universities have actual hardware that you can mess up with. In general, you cannot build as an undergraduate student a quantum computer, but you can calibrate one. The easiest way is going to be with photons. That's the most accessible one. If you want to understand how the building works, then you could use software like Qiskit Metal, which is actually producing a simulation of the actual hardware, and it's cheap, suddenly cheap, as opposed to, and then you can send them over to a lab where they can be fabricated with all the expensive refrigerators and whatnot. So these are Arduino-based experiments in QKD, and I wrote a few things over there. This is a Deutsche setup. Again, they are inviting high school students every year, and these are some of the pamphlets. They trapped dust for us, even though the idea is to trap ions. You know, that dust is enough. They also explained how that works, and it's a dynamic situation where it's like something like a saddle rotating, and the thing is sort of finding a potential well over there. And that's basically our experience in Canada. The thing is that they have the ability to do this. For one thing, they have the money, and for the second thing, all the teachers are basically likely to bring up quantum in high school because it's part of the curriculum. So as I said, there's a club. I have the online proceedings for 2 years, and now they are sort of by themselves, and I want to see what they're going to do. So now I'm going to come over here and I'm going to say, what can I do for you today? It's 9:48, and I'm just going to ask, Jack, how are you?
Good.
Just because you're here. So here's the problem that I want to solve. And can you tell me what exactly you think about it? The problem that I would like to solve is the problem number 9 from the probabilities. Let's read it together, and you give me an idea as to how to approach it. Somebody else online or here can give me an idea, but I'm talking to Jack just for the fun. So you roll 3 dice. Every dice has 6 faces. So what you're going to get is anything from 111 to 666. You can't get more than 666, right? What's the probability that the sum of the 3 numbers is not a prime number? What?
Like there's 3 even numbers.
3 dice.
3 dice.
And so if I roll 2, 5, 1, let's say that's what comes out. 2 plus 5 is 7, plus 1 is 8. Is it a prime number or no?
No.
No, exactly. So I want to know the probability of not getting a prime number. For example, the 8 that you just mentioned. Yes.
So when there are 3 dice, it's the biggest numbers that we can have is 3 times 6.
18. That's absolutely right.
And then we can figure out how many.
That's no, that's
No, go ahead.
Sorry.
That's
How
absolutely
many prime number exists there, and then more or less we can get the percentage, which is probability, or not the percentage, the fraction, and then we get the probability.
That is correct. So what we have been suggested here is this: why don't you just look at all possible cases, and just look at them and see how many give you not a prime number, and see how many give you a prime number, and the sum should be how many? The sum, all the possible cases.
80. And you said that 80.
There's 6
Six.
cases.
There are 6 cases per dice. Could you remind me your name, by the way?
Shiva.
But Shiva, you dropped the class.
Yeah, I dropped it. I just thought I'll see in the first week. And
Oh, that's totally fine. So Shivam was not going to sign up, but then he did sign up, and then he dropped, and now he comes here. And who knows what he's going to do? But there's Shivam.
That's
So-
quantum mechanics.
Shivam is here and not here at the same time. Yeah. So I will give you a grade on.
okay.
Just give yourself a grade, or maybe not. So we'll see what happens. No, and I'm very happy that you're here. I thought it's Shivam, but then it wasn't clear to me. All right. So I think you said that the number of cases is not 18. Do you understand what the number should be, or do you understand what the number should be?
So,
I don't understand.
because there's 6 prime numbers between 3 and 18. And 3 is like the lowest sum you can get with 3 die, and 18 is like the highest sum you can get with 3 die. And so the prime numbers between 3 and 18 are 3, 5, 7, 11, 13, 7.
6 cubed.
So here, although people online may not understand or hear exactly what is being discussed, I think we just set the foundations of this problem. You have 3 dice. Each dice give you 6 numbers. So the total possible situations are going to be 6 times 6 times 6. I don't know, 36 times 6,
6
which is
cubed.
216 or something like that. So let's see if I can log in over here. I took this problem from a class, which has started Saturday. That's taught by Jim Frerichs at Georgetown, called Quantum Mechanics for Everyone. I want to briefly show the thing. So what's my password here? Okay, and of course the problem is in there. So I took this class a while, I got a certificate, took other classes, I got a certificate for a program. So then I'm not sure if he has a problem in this year's. Why don't I go into the one from last year to show you the problem? And so maybe I'm gonna go into this one last year. So this one, I didn't take it for more than like a week, and then I canceled. I had it already, but if I go in here and I say probability, then what I want to clarify is this class is interesting, but it's only teaching, but I mean completely, only, entirely physics. So then I will explain to you later that we in quantum computation do not care too much about the physics, because the physics is about everything, whereas in quantum computation, we have a simpler system and a goal. And things are just set up such that, for example, when you do Python, you have no idea what's the physics of the semiconductors underneath. So in this class, if you just want to learn the basics of quantum mechanics, then he has really nice things about 3-dimensional simulations. And so with the purpose of showing you quantum mechanics, this is an excellent class. I'm going to say that, that's enough, because I mean, it's really, really nice. But when you get to the problems, one of the problems for probability is this one that I'm talking about. And last year, for this class, I actually drew on the board, I have the pictures, all the cases that you were talking about. And then I started counting, and I said, there you go. What happens in this case is that you might actually not be very careful, and you make mistakes, or people can't follow. And then sometimes they don't understand. And then you end up, yelling. And then they say, okay, and it's just your authority. I still don't see, but you keep saying it. So we must have some way of actually making it clear what exactly the calculation is to find those cases, beyond the fact that some person might just say, I still don't understand. So when you go through these exercises. I'm not entirely sure if I can find this problem right away, but I can solve it very quickly in a second with a program. So then I'm gonna come ahead, of course, descriptions, and they're not hard. You just have to, not be tired when you are thinking about this. Let's see. So this is the problem, okay? The answer to this problem, the correct answer is, where is the, wait. What is the, you roll 3 dice, okay? What is the probability that the sum of the 3 numbers is not a prime? And so the answer, just so you know, is in this. I took it from here, right? And you click here, and then here's the answer. This is the answer. And you say, oh, that's what I wanted to say. That's exactly what I wanted to say, right? And you know what? Maybe that's the case. Maybe that's not the case. Maybe you say, I'm not going to go to this. I just don't like the idea. I thought that there would be more clean math rather than me going through these possible cases. But that's a possibility. So if the probability is this or this, I wonder if I can do it here to convince you of it, okay? So I'm going to say, I have 4 minutes left, and I'm going to say, I'm going to write a program that will basically calculate what I would have done by hand, but I'm not going to be involved. And if my program is correct, I also don't get tired. So if we only have 4 minutes, if I don't finish the program, then I want you to think about it so we can start through this program tomorrow. So I'm going to say, this is Python. And I'm going to say, what if I say print 1 plus 2? Then when I hit enter, it's going to print 3. So I say, great, that's how it works. How am I going to write my program? Now, it depends. We have to ask ourselves, how can we go to solve this problem so that people say 8th grader understands this, or maybe a high school, an incoming student, high school, a 6th grader, depending on how much Python they have seen. So I'm going to say 4 dice, D1, okay, in range of, I guess I have to generate 3 dice. So I'm going to say the first thing that I have to do is to import random. And then I have to create a dice. So I'm going to say the dice 1 is going to be random rand int. I guess 1 6. So this is a dice, right? And I will print it. So this is going to take me some time, so I get a 6, okay? But if I run this again, which I do with Shift Enter, then I get a 4. And now I say, you know what? Let me throw this die 10 times. So I'm going to come back over here, say for number in range of 10, I'm going to do this. Throw the dice, shown. So look, 10 times I've thrown the dice and I got 3, 5, 1, 4, 2, 3, whatever, okay? But now I say, you know what, I'm going to throw 3 dice. Didn't we just say so? So D2 is going to be this guy. Same expression, but I get different numbers. Okay, shift, whatever it is. And then I want to get the 3rd dice. And now I'm going to go D1 plus D2 plus D3. So then there are 3 dice over here, and I am actually simulating the process of throwing the dice. And in this case, you know, I'm going to say, I don't know anything at all. So what I'm going to do is I'm going to throw this 1,000 times or 10,000 or 100 times or 1,000,000, and then actually see how many times I get a number that is, that's a simulation. It's not going to be exact, but that's just going to be some number. That's a better way. How about you produce all the combinations, you know, 1 through 6 with 1 through 6 and then 1 through 6 for the other one. So I'll just run the simulation first. Then there is an exact calculation which will simulate the thinking that they showed us. So I'm going to say, do this maybe 100 times. And don't print D1, D3, D2. I mean, calculate how many times. So I'm going to say count is going to be 0. How many times did I get a prime number? And somebody was telling me that I can calculate sum as D1 plus D2 plus D3. And I say, if the sum is a prime number, don't count. Otherwise, count it. So if sum in, now what are the numbers that are prime between 3 and 18? 3 is a prime, 4 is not, 5 is not, 6, 7, 7 is, 8, 9, 10, 11, 12, 13, yes, 14, no, 15, 16, 17, that sounds right, 18, that's it. These are the prime numbers. I made a mistake, then I go back and say apologies and whatever. But if the sum is in there, then I say count, go up by 1, and otherwise don't do anything. So at the end, when you counted how many times you got, this is a simulation, it's not going to
take the least another set because the set will be false. Okay, it's equal.
Is that okay?
It's okay, but I just wondered why you not use sets, why you use
It's there, and my list is basically a set on account and nothing is bigger at all.
Yeah.
So I'm going to say print because we only have like nothing left. So I'm going to take count and divide by the range, which in this case I'm going to 3 times. So here's a very crude way of finding an answer that's not going to be accurate and it's going to vary. But then tomorrow we can find the actual answer, and then we have other ways that for the other problem number 1. So times is equal to, I'll do it 100 times. Let's see, I may have mistakes. It's coming 0.36. What did they say over here? The probability of not trying is going to be 143 over 216. 143 over 216. So if I get 66, you see what I calculated? I calculated the probability of being a prime. Yeah. But you say not? Is that what you were telling me? Sorry. So here's the probability of 62, right? I'm going to say, okay, but let's do it 1,000 times. And that says 667. That's better. If I do it 10,000 times. All right, you get something around the numbers that I see over here. Of course, I want to get 66%, okay? And I might be getting it, but I really want to get the actual answer. Well, I can do that too, except today, the only thing that I've done is to write a program that simulated the game without me doing any effort, except writing the code properly. So we start by looking at simple problems or probabilities in which programming could simplify some of the work that we have to do. That in the end could be the math that we should be doing. So that basically brings us at 10 o'clock. And we have to stop for today. Any questions as we leave people online or here? For tomorrow, please watch Terry's video. And please look over the problems that I posted. See first how we can finish this problem. And then also the one that says you're playing this game and they give you $4 if you win. And they take your chip if you lose. Is it a fair game? So if it's fair, tell me why. And if it's not fair, define fair. And how would you make it fair? So that's just a problem for you to think about. So tomorrow I'm going to, for sure, finish this, do the other part of it, do the other problem, and then write the first Qiskit code so you can see how the circuit gets together and how you take this notebook. I'll find it here tomorrow, and then put it on GitHub. I will follow up with you individually to make sure that you create a GitHub account. Send me the username so I can send you an invite so you can accept, so you can then upload the work. We have a question in the chat. Let's see what the question is.
Wait, what's the fractional answer? Is it 1? Like,
the fraction is going to be this one.
is it 143?
143 over 216, because 216 is 6 to the third. So, Ahmad, you can find this recording as soon as I post it. Let me show you. I'm sharing the screen, I think, right? So if I go to, let's go over here and close. So Ahmad, if you remember, this is the website, right? You click on it and you go to 17. And it says over here, when the recording is available, it will be posted here. There's this hand. This is Michael Jackson's glove, just so you know. In case you want to know precisely what this is, that's what it is. It's pointing. So watch the glove from Michael Jackson, and this will become a link around noon. Ahmad, is that acceptable, the answer? Yes, perfect. Thank you so much. All right, we have to stop here. And I will see you either in Zoom office hours or tomorrow.
Technically, I have problem accessing your homepage. Could it be repeat the dates or no?
But we can do it now. I'm going to stop the recording and say thank you very much for everybody who attended. I'm going to stop the recording, and actually I'm going to stop the share the screen somehow. Where So thank you once again for everybody. I'm gonna stop sharing. This is me. This one here is right here is and then I'm gonna look at his program. Bye bye. Thank you. See you later. So then I'm going to say end.